Let's continue with section 6.3 on exponential functions. Example 3, we have another exponential function here to graph using transformations. So we have f of x equals 2 to the negative x. So again, the parent function would be f of x equals 2 to the x. So in the comparison of the two, we see one transformation. Is it occurring inside the function or outside? Well, it's inside. You have to apply that negative before you raise 2 to the power. So it's inside the function. That means it is has a horizontal effect, which affects our x coordinates. The y coordinates will not be affected. So the only thing we have is a horizontal what? It's not a shift, right? Because that would be plus or minus. We're not multiplying. It's not a multiplier out in front, so it's not a stretch or compression. This is one of our reflections. So it's a horizontal flip. And when you flip horizontally, that means you reflect over the y-axis. So we said that's going to affect the x values. And if you take a point like the point 1, 1 and reflect it over the y-axis, it's the point negative 1, 1. 1, 1 becomes negative 1, 1. So what happens? The x coordinates all change sign. So we will multiply x by negative 1 to change the sign. All right, our 3 points are negative 1, 1 over a is 2, 0, 1, and 1a is 2. Okay, all of our x coordinates will stay the same. All of the y coordinates will change sign. Negative 1 times negative 1 is positive 1. Negative 1 times 0 is 0. Negative 1 times 1 is negative 1. So we have the point 1, 1/2, 0, 1. So that one didn't change, but notice it was on the y-axis. And we said we're going to reflect over the y-axis, so any point on there is just going to stay there, right? And then the point, let's see, we have 1, 1/2, 0, 1, and negative 1, 2. So instead of going like this, we have flipped, and now we're going, it looks like this. We've completely flipped over the y-axis. Okay, the domain is still all real numbers. The range, we haven't adjusted vertically, so our range hasn't changed. It's from 0 to positive infinity. It's the same as for the parent. And what about the horizontal asymptote? It's the horizontal line, y equals 0. We did not change that either. So we still have a horizontal asymptote. It's just that instead of approaching the asymptote as we go to negative infinity, now we're approaching it as we go to positive infinity. So we had a horizontal flip. That was all we saw that time. Let's look at example 4. Now we have, there's that horizontal flip we just saw, but now we have a negative sign outside the function. So comparing that to this parent function, sometimes I'm writing that just to help us see what the difference is. So we see that the first thing that's happening is inside the function. Again, we have our horizontal flip. And I'll just put multiply x by negative 1. But what does this negative do on the outside of the function? Well, outside the function means vertical, and the negation means a flip. So we're also going to flip over the x-axis. So we'll be multiplying our y values by negative 1. So our 3 points, again, negative 1, 1 over a is 2, 0, 1, and 1, 2. Okay, so we're essentially changing the signs of both variables. So negative 1 becomes 1, positive 1/2 becomes negative 1/2. 0, of course, is still 0, but 1 becomes negative 1. 1 becomes negative 1, 2 becomes negative 2. So remember, our parent function would look something like this. So we're going to flip over the y and over the x. Let's see where we end up. At 1, negative 1/2. At 0, negative 1. And at negative 1, negative 2. Okay? So our domain has not changed. It's still all real numbers. Our range, though, low to high, instead of 0 to infinity, we're going from negative infinity up to 0, but of course we'll never get there. And the horizontal line, that is our horizontal asymptote, is still the x-axis because we didn't shift vertically in any direction. So y equals 0.